Hello again, my little mathematicians. Today we're going to do a foldable that's reviewing how to find the area of all of our basic shapes. Quadrilaterals, which includes rectangles, squares, trapezoids, rhombuses, all of those are quadrilaterals, four-sided figures. Triangles, three-sided figures. And then what we mean by polygons is composite figures, okay? So like multiple shapes put together. This is a good thing to review because it's going to all be on our upcoming quiz. And then when we review individual shapes, this is a good time to review right now before we do the unit on surface area. Because remember, when we have a 3D shape, it's made up of individual polygons, whether they be triangles or quadrilaterals. All right. So this foldable, okay, hopefully you follow directions. When you printed it out, you're going to print pages 1 through 4, double-sided, flip along the short side. So once you have that, you're going to put down the piece of paper that says polygons. Okay, so the piece of paper that says polygons, go ahead and put that down flat on the table. Then find the piece of paper that says triangles. Okay, and you're going to put triangles down. And then if you fold it down, you should see that then quadrilaterals is right on top. And you'll fold it down and you will have the calculating area right on top. And then you fold it down. This is how it's going to look, okay? And then once it's all folded and it looks like this, you're going to cut along that line, okay? Now, I didn't do mine double-sided just yet and fold it because it's a little bit more complex when I'm trying to make the video. But I suggest that you have it folded like this. Remember, put polygons down first, then put triangles, fold it over, then you should see quadrilaterals and calculating area on top. Okay, so your foldable looks like that. Now it's a lot easier for us to go through the foldable together. So we're going to start, first off, with these 3 different quadrilaterals. This one is a square because that little indicator right there, that tick mark, means that all of those are the same measurement. Okay, this one is a rectangle because this isn't the same as this. And this is a parallelogram because this side is parallel to this side is parallel to this side, but they're not necessarily all the same length and they don't meet at right angles in the corners, so it's not a rectangle. But regardless of whether it's a square, a rectangle, or a parallelogram, they all have the same formula of base times height. So you look for that little indicator of a right angle and that connects your base to your height. And we said when you see this little tick mark, that means that this is the same as this. So this is 7 and this is 7. 7 times 7 is 49. So this has an area of 49 inches squared. This one right here, again, look for the little right angle, that little box indicating a right angle, that connects your base to your height. So your base is 3, your height is 8. And 3 times 8 is 24. So this is 24 centimeters squared for your area. Okay, here's your little box indicating a 90-degree angle, so that connects your height to your base. Your height is 12, your base is 15. When you type that into your calculator, 15 times 12, you should have gotten 180 yards squared. Okay, now if you already have it folded, 4 and 5 should be right beneath you. If you didn't print it out correctly, you have to search for it. So 4 and 5, these are still both quadrilaterals, but this is a trapezoid and this is a rhombus. So they each have different formulas. A trapezoid has the formula of base 1 plus base 2 times the height divided by 2. And a rhombus has a formula of diagonal 1 times diagonal 2 divided by 2. So let's go ahead and focus on problem 4, the trapezoid first. My 2 bases are the ones that are parallel to each other, so they don't intersect, and it's connected by that vertical height. Okay, and how I know this wasn't a parallelogram is because unlike a parallelogram, where see this side and this side are parallel and this side and this side are parallel, they will never intersect. These don't intersect, but if these kept extending, they would intersect. So there's only one pair of parallel sides in a trapezoid, and you can see The opposite sides aren't equal, okay? So one of my bases is 18. My other base is 10. And then it says the height, so look for that little right angle that connects your two bases. That height measurement is 8, and you're going to divide it by 2. First thing you want to do is add inside of those parentheses. 18 plus 10 is 28 times 8 divided by 2. You could multiply 28 times 8 and then divide by 2, but why not cross cancel, deal smaller numbers. 2 divided by 2 is 1. 28 divided by 2 is 14. And now you have 14 times 8, which is 112 over 1, which is just 112, and it's feet squared. Okay, so that was for my trapezoid. Now I'm moving on to my rhombus. My rhombus is diagonal 1 times diagonal 2. Diagonal is what goes from one corner of your box to the opposite one. So this diagonal has a measurement of 11, and this diagonal has a measurement of 8. And then you're going to put that over 2. Well, 2 goes into 8 4 times, and 2 divided by 2 is 1. 11 times 4 is 44 over 1, and 44 over 1 is just 44. So this has a unit of 44 miles squared. Okay? Those are all the quadrilaterals that we're reviewing. So again, we had squares where all sides are equal, rectangles, they meet at 90 degrees in the corner, and all side lengths aren't equal. This and this are equal, and this are equal, but not all 4 are equal. A parallelogram where you have this and this parallel to each other, this and this parallel to each other, these two sides are equal, and these two sides are equal. Okay? And then we also have a trapezoid, okay, where only one side of parallel sides are equal, and a rhombus, where they don't meet at right angles, but all 4 sides are the same. So it's like a parallelogram, but where all side lengths are the same. So then you would use it finding the diagonals to find your area. Okay, those are a quick review of all the quadrilaterals that we've covered. Okay, that was problem 5. If we move on to problem 6, 7, 8, and 9, you will see that this is our review of the different type of triangles that we'll see. Regardless of whatever type of triangle it is, it's always the formula of base times height divided by 2. So let's go ahead and write that for each of my triangles. Okay. And you always want to look for that little right angle indicating, that little box indicating 90-degree angle. That connects your height of 5 to your base of 8. 2 goes into 8 4 times, and 2 divided by 2 is 1. 4 times 5 is 20. 20 over 1 is just 20, and that is meters squared. Now remember, you can always pause the video at any point in time and try to figure these out on your own, and then unpause it, press the play button, and then check yourself. In fact, I highly recommend you do that. Okay, again, look for this little box. That connects your base to your height. So your base is 12, your height is 17. Put it over 2. 2 goes into 12 6 times. 2 divided by 2 is 1. 6 times 17 is 102 over 1, so just 102, and that was miles squared. For this one, here's your right angle connecting your height to your base. So 10 by 10 this time, they're both the same. 2 goes into 10 5 times. 2 divided by 2 is 1. 5 times 10 is 50 over 1, which is just 50, and that's centimeters squared. Okay, this one's a little bit trickier. Note how your right angle doesn't necessarily have to be part of the outer shape, the outer edge. It could be sometimes inside the figure or outside the figure, but it's just saying that it comes down perpendicularly to your base. So the height is 7 and your base is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 7 times 2 is 14 over 1 is just 14 kilometers squared. And if you're like, all right, that's great, that was pretty obvious, I don't know why you specified that. It's because in the future, they might give you other measurements and be like, oh, hey, by the way, this is 8 and this right here is 10. And then you're like, do I use the 4 and the 8? Do I use this 10 at all? 4 plus 8 plus 10 would tell you the 3 measurements to add together to get the perimeter. When you're finding the area, you just look for that box and it connects your height to your base. So you just use the 4 and the 7. And that's why I specified that out. If they give you extra numbers, sometimes that's if they were asking you to find the perimeter. And they're testing you to see, do you know that you don't use the 8 in this case? You just use the 7 and the 4. Okay, so that was our quick review on triangles. So if you find the next, go ahead and flip it or go on a scavenger hunt if you printed them all separately. Number 10, this is referred to as a polygon or a composite figure because it's made up of different shapes. So there's 2 ways you could do it. You could either draw a line here and try to see if you could do this shape plus this shape, or you could do it here and do the entire rectangle minus this triangle. So it's just a matter of preference. I think the easier way is to do the minus one. So if you do the entire rectangle minus that little triangular piece right there, then that would give you, let's see, that weird looking shape like that, right? I just subtracted out that little triangle. Okay, so a rectangle has a formula of base times height, and a triangle has a formula of base times height divided by 2. So that big, large rectangle has a measurement of 12 by 22. Okay, minus, for the triangle right here, this is a right angle, it has a base of 8. The height is not so obvious, but I know if this side is 22, that entire side is 22. So see if you can figure out what you think I would do to find that missing piece. And if you think that you would go, well, from here to here is 12 plus what equals 22, you were right. 12 plus what is 22? 10. Okay? So my height is 10 of my triangle and my base is 8. And then put that over 2. So let's just go ahead and simplify. 12 times 22 is 264 minus, well, 2 can go into 10 5 times, and 2 divided by 2 is 1. 8 times 5 is 40. 40 over 1 is just 40. Now you have 264 minus 40, and that gives you a total area of 224 feet squared. That's if I were to solve that problem doing subtraction. But again, I told you, you also could have just cut the shape here and added this rectangle plus this trapezoid. Okay, so you have a rectangle plus a trapezoid. So base times height plus base 1 plus base 2 times the height divided by 2. Either way you do this, it's just a matter of preference, whichever you think is easier. Okay, so let's see. For this top rectangle, which if I look more closely, it's actually a square because it's 12 by 12. So 12 by 12, base times height is just 12 times 12. Plus my trapezoid right here, I know the one base is 12. Plus I need to find this base right here. Well, this is 12, this is 12. 8 plus what makes 12? 4. So this little part right here is 4. My height that connects this base to this base is right here, which is the same as this. We already figured that out to be 10. Because from here to here is 12. 12 plus what is 22? 10. So my perpendicular height was 10. Let's go ahead and simplify that. 12 times 12 is 144. Plus 12 plus 4 is 16 times 10 divided by 2. So 2 goes into 16 8 times, and 2 divided by 2 is 1. 8 times 10 is 80. So the area of my trapezoid was 80. I'm going to add that to the area of my top square. And when you type into your calculator 144 plus 80, we should get the same answer that we got up here. And we did, 224 feet squared. So you can solve it either by dividing your shape up and adding the individual shapes together, or finding the big space and then subtracting out this little part that's not actually included. It's just a matter of preference, whichever way you think is easier. Okay, that is 1 through 10. There's one more problem I want us to try. It's another composite figure. This one, if I were to do the subtracting way, I'd have to subtract this guy and then find that whole measure. It doesn't make any sense to do this one the subtraction way. I would only do this one the adding way. So let's go ahead and cut it right here. I have that little tiny top square plus that bottom rectangle. They're both regular, like squares or rectangles, so base times height for my formula. And let's go ahead and see what it is. From here to here is 4. And I know that this entire length is the same as this. So the whole measurement should be 13, right? Well, you have 7 plus 2, which is 9. 9 plus what is 13? 4. And let's just double check. 2 plus 4 is 6. 6 plus 7 is 13. And that should be the same as this. So this little missing piece right here is 4 by 4. So that makes up that little tiny, the measurements of that tiny square. And then for this guy, this side is 7 and this side is 13. That was pretty nice. So 13 by 7. Okay, base times height plus this base times that height. And then 4 times 4 is 16 plus 13 times 7 is 91. So 91 is the area of this rectangle right here. 16 is the area of that top square right there. Go ahead and add those two together, and that will tell you the total area of that composite shape, which is 107 meters squared. Okay, hopefully that was a pretty helpful review of all the different quadrilaterals, triangles, and composite figures or polygons. Okay, good job, my little mathematicians. You're getting smarter and smarter each day.